pursuit. GDC construction and operation involves a variety of advanced technologies and strategies. For example, first, one must build an inventory that includes IT systems, all mechanical and electrical equipment, as well as supported infrastructure. Operating data must then be gathered and analyzed to determine how much energy each piece of equipment is using. Once this baseline is established, proposed implementation strategies must factor in new requirements and growth estimates. Simply replacing older, inefficient equipment will not get the job done. In fact, this approach could adversely affect existing data centers due to insufficient power and cooling capacities. Our next speaker will describe a three-phase strategy that has proven successful in setting up green data centers. The task sounds daunting, and to get an explanation as to why such an effort is worthwhile, please join me in welcoming John Cilia, a managing consultant in the IBM Systems and Technology Group. John, welcome.
Thank you, Jim. Hello, everybody. I would like to try to go through an implementation of a green data center based on a three-phase approach. The definition of a green data center, and this is my own, it's a little long one, but this is the best way I could define one, was a secure enclosed room where servers, storage system, telecommunication equipment, and support systems are optimally automated, operated, managed, and supported in a way that reduces personnel, hardware, software, utility costs, and carbon footprint, while continuing to securely run the business and deliver reliable productivity, performance, and availability as well. Therefore, this is my definition, and I'm sure we all have one as well. The other thing is a trend on designing new data center. You found out that today, for example, ASHRAE standard TC 9.9 guidelines were produced to indicate the change in requirements to specification, requirement, and design for green data centers. And therefore, the new value that you can see are now wider than they used to be in the past, and the expansion of between the low and high end temperature humidity have been changed. And therefore, because of that, now we are looking at providing a support, environment support for the equipment versus what used to be maybe in the past more an environment support for the people staying within the data center. And therefore, we are looking at now new values that expand the high and low end of temperature humidity as well to save energy. Now, what is the phase approach we are suggesting at this point? Phase one is what we call the setting goal and objectives. And the key here is to create a steering committee that understands two things. One is the IT environment, which is the information technology environment, telecommunications, security, and major production application program that run your enterprise or your company, whatever. And the other aspect is your support services, which is your power and cooling support systems, infrastructure, and related services to run your data center. These two different environments or aspect of a data center are very important, and it's very hard to locate or having a group of people who can understand both of them. Therefore, in some cases, the steering committees that you're going to try to put together may require to have some additional training in certain area of these environments. The key here for the steering committee is to actually develop and submit a kind of report to management to define the project goals and objectives of an initiative, a green data center initiative, an overview of the existing infrastructures, and also an overall strategic plan on how to start a green data center initiative. This kind of proposal will be submitted to management for their final approval to go ahead and start a green data center initiative. Now, in this report, what's going to be provided is a very high-level overview, for example, and this is an example of some of the things we do in that phase, is an overview of your IT power and cooling infrastructures to define what you have, how many data centers, the size, the type of equipment, and how things work and connected together. This is going to be your baseline for the introduction of what's going to happen and what you want to go and assess later on. The phase 2 is now the gathering and the analysis information requirement. At that time, after you get your management approval, what you have to do is to assign team members to your team for providing the gathering and analysis information for that particular phase. Now, we are suggesting a minimum of 2 people, and very different people. One is the IT specialist to understand your hardware, your software, networking, security, and so forth. And another one which is more the facility aspect of it, which is electrical, mechanical engineering type of things. I know it's very difficult sometimes to, even within 2 people, to get this kind of knowledge base. And again, this may require or to have more people specialize in different environment or areas, or is to have these people to get some additional training to understand better some of this environment that you want to expand and review, analyze later on. Now, assuming that you got your team and you got the funding necessary to assess your existing data center and support services, the key here is to record all this asset information and actual measurement values. What we are saying here is you need to have now, based on the previous phase 1 overview of your infrastructure, is now to focus in each independent environment and get measurement, record all your assets, and figure out how you can measure all these points in different systems. And based on that, you will come up with a list of equipment, their usage, the names, how many you have, what their value, actually energy used, and so forth. And based on this finding, you are going to define the baseline for future energy usage. And that is very important to start with. Then the phase 2A we call is the gathering information. And what you want to do is, as I just mentioned earlier, is to get through your IT equipment, mechanical, electrical equipment, and get an inventory of all this equipment, draw the physical location of each of your assets, for example, your data center, to figure out exactly where they are physically connected, piping, wiring, and so forth, and defining, the energy usage as well. Finally, when you do the audit of this equipment, you will collect and record all this information, temperature, pressure, power usage, and so forth, nameplates of the equipment, as well as on your data center, the air and water flow, for example, to feed your data center, and get the monitoring aspect of these values to make sure you understand what's used today in your data center. This is a list of typical area and equipment that you find out. For example, if you look at the raised floor area, you're going to look at your IT equipment, servers, and they can be a small farm of servers. It can be medium size, like Unix-based servers, as well as high-density enterprise systems, or like Linux, ZOS, and so forth. You can have different type of racks, from high-density racks to multiple standalone racks, where you have servers and storage, as well as communication, telecommunication, and modems, or whatever you use for these particular standalone systems. You have storage devices, and you will look at all the network communication as well, and the workstation involved, if any, that you may have a control room there that monitor and manage your data center as well. The other aspect of it is to look at the electrical equipment that you have on your data center. And for example, you're going to look at your uninterruptible power supply, your PA system, your PDUs, power distribution units, and your backup system as well. Your switches, your transformers, circuit breakers, and so forth. And that is something that you have to capture and record as well. We have looking at the mechanical equipment, and in this case we're looking at the computer room air conditioning, and we have two different CRACs here. And the other one is computer room air handling. The difference is basically your computer air conditioning is your standard DX expansion unit, where you have an evaporator inside of your units, condenser outside, it can be air or water cooled systems. And the other one is a standard CRAC unit with air handling, where you have chill water going through a coil with fan, pulling the cold air throughout the race floor. And that's a difference between air conditioning CRAC units and computer room air handling systems. You want to look at your pumps, your chiller, cooling towers, fan, heat exchanger if you have, how you are using a fresh air intake system in your data center, because it can be utilized later on to add more fresh air from outside to cool your data center, as well as your HVAC system, and see how you can implement that as well later on. In this case, we're going to go to assessing and developing a power and cooling baseline, and this is very key to your success. You want to start with a baseline. You want to understand where you are today before you start to implement any of your suggested projects. Like this, you can go back later on to your management and say, here where we were, and here's what we accomplished with that particular project, and therefore that is going to be helpful to you later on to actually go back to your management for another project to request some additional fundings to complete it. You have to come back and do your baseline and look at all your existing energy bills. So you have oil, gas, steam, electricity, and so forth. You need to use all this information as you used to probably do for your building automation energy management systems and project like that. Then you need to do that. You need to calculate and track monthly your energy usage for your data center. It's very important you do that. And you need to assess your power and cooling requirements and develop your thermal analysis and CFD, your computational fluidic dynamics modeling, which is basically a good way to say, if I have this kind of scenario, or if I'm going to expand in 6 months and add additional servers to this particular data center, where should I put them? What will happen to my load, and how can I figure out the best way to implement it? And it's very important to do that. You want to review some of your processes. For example, you have a review, move, add, delete IT equipment process, or for your mechanical equipment and so forth. So many times I go in a data center and I find out some of the equipment they have there are turned off and not used, but they never removed it from the site. There is no reason for that. Therefore, you want to review your move, add, delete equipment process. You want to review your purchasing process as well to help you to know, first of all, when a new equipment is going to come, that everybody is in sync. Your IT manager, your facility manager is aware of what's happening, instead of at the last moment somebody calls you from your warehouse and say, by the way, Joe, I have a big rack here for you to connect to your data center. And this happened several times, I'm sure, to you guys too as well. You want to research renewable energy solutions, such as chillers, for example. It is very important today that you look at these options, because most of the sites are getting to a point where the electrical company are not able to provide them additional power to sustain their additional load for future loads or something like that. And therefore, you want to look at some other way to do that. One of the way is to use a macro turbine, for example, where you can actually generate energy at your site, while you can use the energy wasted from your macro turbine, the heat that the system generate, and use that to generate, for example, chill water through an absorption chiller, or to use to heat some hot water throughout your site. You want to investigate the trend. And for example, we are focusing a lot lately on consolidation and virtualization, which is basically migrating 2, 3, 4 different data centers maybe to 1 or 2. And virtualization is actually taking different applications and consolidated them together through maybe 1 or 2 machines instead of having 300, 400 machines around it. This is very important, and this will save you a tremendous amount of energy, maintenance cost to support and maintain your systems, as well as the reduction of software licensing and maintenance cost. Therefore, these are some of the suggested solutions and suggestions we had done throughout the past few years. The other thing that you want to look at is, when you do your analysis, is to focus on existing sites or existing incentive programs that the federal government, local site, and your utility company may provide you today to help you to implement your solutions. In conclusion, what you want to do in phase 2 here is to come up with another report that will identify all your assets at IT, power, and cooling based on critical and non-critical equipment. It's very important you separate both of them, and based on that, to come up with a set of prioritized recommendations from, for example, a no-cost or low-cost implementation project to a more complex and more costly projects. And usually management is going to focus on, obviously, the low cost or no cost aspect of it, but it's a good aspect, it's a good way to just go through this kind of presentation to your management for future usage. Now, if we look at what we did in the past, some of the previous assessment we did, we had some recommendation. For example, we tell a customer, after we did all this temperature, humidity readout, CFMs, CRACs, and so forth, we tell them maybe, hey, you have to balance your air or your water flow in your raised floor. You may want to implement hot and cold aisle best practices for your data center to be more efficient. You may have to turn 1 or 2 CRACs units because you don't need it in certain areas of your raised floor. Okay, you want to verify that all equipment, for example, are connected to your higher voltage available for that particular equipment at your local site. It's very important because you're going to lose less energy for the same thing. Therefore, if you're running a machine or a sample server for 120 volts, and you have the capability to connect to a 208 volt, and the server can provide you that capability, we suggest strongly that you go after that and just simply connect to a 208 volt, which is no cost to you usually. If you have some critical equipment or single power cord equipment, and you find out this is a very critical equipment for you, therefore you want to be able to have some kind of backup systems. In this case, you can add a static transfer switch to this unit, to this equipment, or you can actually replace it with a dual power cord system. We talk about implementation, hot and cold aisle. Implement the servers and data storage consolidation and virtualization and communication as well. What you want to do is you want to understand, since you understand now what kind of equipment you have, what kind of servers you have, what kind of operating system you are running, you want to focus on that and see if you can actually replace, let's say you have 200 servers running on Windows, and some of them can be compressed, and you can replace maybe 200 of these servers with a couple racks. That will be a nice consolidation project for you to do. Now you can look at the virtualization aspect of it, which is basically to look at the software. And let's say you have 5 servers or 10 servers serving using for email. Okay, you may have one server running the same email system with one license and one program, and therefore you want to look at virtualization and consolidation to reduce the number of hardware, reducing your energy cost, and reduce your carbon footprint as well. One of the things that we suggest strongly is if you have old UPS systems, and by old, sometime 3 years it's old, you'll find out that the efficiency of UPS system can be 80%, and the new ones can run over 90–95%. And that savings can be very high if you have some system like that, and to look at that as well. This is a suggested top 10 best practices for a sustainable green data center. I know that we talk many of these things here today, but the key here is to begin with an enterprise green data center initiative goal that we exploring financial support from the utility company, the government, and local government as well, and to develop a set of governance for green data center which is approved obviously by your upper management. You want to measure, monitor, track, manage all the assets. You want to make sure you understand where all your energy, that's electrical, gas, steam, oil, etc., and where it's going, and how you can come up with a way to figure out what is your efficiency. For example, you can have a PUE, power useness efficiency, that give you the ratio between the total energy used for your site and the energy used for your IT equipment. Is one simple way to figure out something like that. And again, you have to track it and monitor that. You have to be able to compare month by month, for example, where you were and where you are after you're implementing a project, and that will be very helpful again to sell you upper management to the next step. Improve all the processes, operation, maintenance, we talked about that. That will save, obviously, if you do consolidation of virtualization, you have less equipment, you have less maintenance, you have less licensing cost, and you have probably less people to manage your servers. For example, user ID and password. If you have 200 servers, with the same amount of people, but now you have only 2 or 3 servers, and you are managing the user ID and password on these things, you're probably going to need a lot less people to manage that. Replace your equipment, the end-of-life equipment, with a more efficient equipment. It's very, today you're going to see that most of the equipment that you're purchasing, that it's IT, power, or cooling, they are all designed to be a lot more efficient than in the past. And therefore, if your equipments are more than 3 years old, you may want to look at that and see if it's possible to replace them and be cost effective as well. Make sure that you can you verify and you can go back after all the equipment to make sure that the power connections to your equipment is based on the highest voltage that the system can support to save you energy, as well as if you have some systems that are non-critical and you have, for example, a dual power supply, you may want to disconnect one of them in non-mission critical systems. Then it's something to look at some time. You want to initiate the data center energy efficiency assessments. This is very important as we talk under phase 2 to get all your assets, make all the measurements. You want to be able to get your thermal modeling, if it's possible, of your data center by reading your air and water temperature throughout the data center, and after to come up with some different scenarios to figure out how you can do your CFDs. Exploit the consolidation and virtualization, we talked that a few times now, and be able to integrate all your systems and be able to monitor them as well. That is the final suggestions where we think that you will be able to save most of the energy by integrating your IT equipment, your power and cooling equipment as well, be able to manage all that and to be able to figure out how to optimize the best way you can your environment and your data center. Finally, we got the phase 3, which is the implementation. In this case, what we are looking here is very simple as far as the implementation, because what you're looking is more, or if you have internally enough people to generate a project and be able to actually install this project yourself, you know, it's just a matter of how you want to manage a project management approach for this kind of project. But you can also, if you don't have internally enough people to do that, you want to prepare a bid package and go out for bid to third-party companies and be able to, you know, award the contract like you have been doing throughout the years, irrelevant if it's a green data center or not. This is a standard process for project management, and therefore you want to do that, be able to follow up your project until it's completed, and be able to train your people after the project is completed, do a measurement verification solution work to verify that basically what you specify is actually done properly, and you can verify that. And finally, you can take over the responsibility to maintain and support your project. If you have any questions, I will be happy to answer them.
Well, John, I do have some questions right here, and the first one says, since data centers consume 20 to 30 times more power per square foot than a standard office building, why did we not focus on this problem earlier?
Jim, this is a great question. In my opinion, I think there is two major reasons. First, a data center is the heart of any business and almost always considered as mission critical. Therefore, management has been reluctant to touch any equipment that is used to run and or support a data center. The second reason is that energy management technology surrounding the IT equipment was lacking, but now because of increasing energy costs and slowdown of the global economy, management is willing to look at the highest energy user in their company in order to save energy and reduce their cost.
All right, this next one says, I've been asked to add more high-density racks, 25 to 30 kilowatts each, in my existing data center. My computer room air handler units are running at almost full load, and I have no more space for an additional unit. Any suggestions?
Since chill water is available to feed your CRAC units, you may want to see if it is feasible to connect your existing chill water main line and add a water-cooled rear door heat exchanger to each of your high-density racks. The rear door exchanger provides 1% sensitive cooling and replaces the existing rear door of your rack.
All right, here's our next one. We will be adding more IT equipment to our raised floor, and our utility company cannot provide us with more power. Any suggestions here?
One of our clients was in the same situation you are today, and we were asked to analyze and recommend one or more solutions. During the gathering and analysis phase, we recommended two solutions. One is revamp or replace 2 or 3 of their small electrical boiler with gas boiler and relocate power to the data center. The other one was to evaluate the cost to use natural gas with macro turbine to generate electricity to their data center and use them to supply power to their new racks, as well as using them as a UPS systems in the event that electrical power is interrupted.
All right, our next one says, our management has asked us to monitor temperature inside our racks as well as our power usage and cost in our data centers. We have no power monitoring capability at this time. What do you suggest?
I would suggest that you search IBM Systems Director Active Energy Management on the web. This application software is free of charge for its monitoring function and capability and can be downloaded to your PC. It is a central point of control for aggregating and managing systems. It is a web-enabled and available for AIX, IBM I, Windows, Linux on Power, Linux on i86, and Linux on System Z as well. The software itself come up with existing interface to few CRACs, UPS and PDUs unit manufacturers that are already inherent with the solutions.
Okay, John Cilia of IBM, we're going to have to wrap up the questions right there. We appreciate the time you've spent with us here today.
Thank you, Jim. Thank you for having me.
You can stay up to speed every day with information delivered right to your inbox. Global Spec offers more than 60 online publications filled with the latest advances in your area of expertise.